We are ready for lesson 3.2 exercises. This lesson involved the other four trigonometric functions: tangent, cotangent, secant, and cosecant. And the exercises I will work are here. So try these. They come from OpenStax Precalculus 2E, and then come back to the video where we'll go over the full solutions. Here at number 20, we want to evaluate the cosecant of 11 pi over 6. First, we need to figure out where this angle is. And you notice I already have drawn an initial side and I have drawn a unit circle. Well, 11 pi over 6, this is 12 pi over 6, or 2 pi minus pi over 6. So we are going to be approximately here, okay, where our reference angle is pi over 6. And we are in quadrant 4, determine the side of this angle. So this would be, well, cosecant is 1 over the sine, so this will be 1 over the sine of 11 pi over 6. Now, in quadrant 4, the sine is negative. So this will be 1 over, well, pi over 6, our reference angle, that has sine 1/2. This is 1 over negative 1/2, which is negative 2. (23) is the secant of 3 pi over 4. Similar to above, we can first think about 3 pi over 4. This is pi minus pi over 4. And so this tells me my reference angle. The reference angle is pi over 4, but also let's draw this angle, or at least draw the terminal side. Here I have the initial side, and if we go to pi, that would be here. Now subtract pi over 4. This will be here. Well, we notice this is in quadrant 2, and the sine is positive, the cosine is negative, and secant is 1 over cosine. So we want 1 over the cosine of 3 pi over 4. This would be 1 over, the cosine here is negative, so we would have negative. Pi over 4 tells us square root 2 over 2. This is minus 2 divided by square root 2. Now, this is an answer, but if you say multiply by square root 2 over 2 divided by square root 2 over 2, we could just write this as negative square root 2. That would be another way to write the exact same number. The only difference is we don't have a square root in the denominator, so I think I'll leave my answer like this. The next one is the tangent of 8 pi over 3. 8 pi over 3. Well, here's how I'm going to think about this angle. 8 pi over 3. This is, say, 9 pi over 3, which is 3 pi minus pi over 3. And so now you see our reference angle. The reference angle here is pi over 3. But also let us sketch it. Here we have to think, what is 3 pi? Well, go all the way around, 2 pi. And 1 more pi is 3 pi, is here. Now we have to back up pi over 3. So it's going to be quadrant 2, just like the last example, will be something like this. Okay, we want tangent, which is sine over cosine. So this is going to be the sine of 8 pi over 3 divided by the cosine of 8 pi over 3. With a reference angle pi over 3, the sine is square root 3 over 2. And the cosine is 1/2. But we have to think about quadrant. In quadrant 2, you can see sine is positive, cosine is negative. So I need a negative sign here. And when I invert and multiply, I just get negative the square root of 3. This would be my final answer here. 38 is a little different. We are given the sine of t is 3 over 4. We are given t is in quadrant 2. So this means we are here. And then we want to find the other 5 trigonometric functions. Okay, the first one we're going to find is the cosine because, and this is very much like we were doing in the last exercises video, we know cosine squared plus sine squared is 1. And so we have cosine squared plus 3/4 squared is 1. And so we get cosine squared t would be 1 minus, well, when I square 3/4, I get 9/16. One more step, we have cosine squared t. This would be 16 minus 9/16, which is 7/16. Okay, now here's where I need to use my quadrant because I'm in quadrant 2. And here the cosine is negative. So cosine t is going to be negative, I'll write it this way, the square root of 7 divided by 4. Okay, very, very, very similar to the kind of things we were doing in the last exercises video, except we have 4 more trigonometric functions to find. Everything else comes from sine and cosine. So for example, the secant of t, this would be minus 4 over the square root of 7. Which you could leave like this, right? Or you could multiply by square root 7 divided by square root 7 and write this as minus 4 times the square root of 7 over 7. That would be a way to not, if you wanted to write it where you do not have square root in your denominator. Then we need cosecant. This is 4/3. This was 1 over sine t, and we're given the sine. But now we have 2 more. We have the tangent of t. This is sine divided by cosine. What happens when you invert and multiply here? Well, I get negative 3 divided by the square root of 7, which once again, if I don't want the square root in the denominator, I could write this as minus 3 times the square root of 7 divided by 7. What we're doing here really is we multiply by square root 7 divided by square root 7, and we get this. So we have one more here. The last one is the cotangent, and this would be cosine over sine. So minus the square root of 7 over 4 divided by 3/4. And here when we invert and multiply, we get minus the square root of 7 divided by 3. So here we had to find, we were given one trig function and we were given the quadrant, and we had to find all of the others. So here's the secant, cosecant, tangent, and cotangent. Our last question, 39, is very similar. Here we are in quadrant 3. So let me highlight the quadrant we are in. It is down here. In quadrant 3, sine and cosine are both negative. And we're given the cosine. It's negative 1/3. We want to find the other 5 trigonometric functions. So just like in the last example, I first used that cosine squared plus sine squared is 1. And here I have minus 1/3 squared plus sine squared is 1. I will get that the sine squared of t, well, when I square negative 1/3, I get 1/9. So this will be 1 minus 1/9. We have that the sine squared of t is 8 divided by 9. Now, terminal side is in quadrant 3. And so the sign is negative. The sine of t will be negative, like this, square root 8 divided by 9. Now, I could write this as a square root of 8 in my numerator, and the denominator will be 3, which is the square root of 9. Maybe I will simplify just slightly more. Because we have 8 is 4 times 2. If you take the square root of 8, it's the square root of 4 times 2, which is 2 times the square root of 2. So here I will write this as 2 times the square root of 2. Okay, so here is my sine value. From this, and knowing cosine, we can get all of the other trigonometric functions. The secant of t, well, this is just 1 over cosine. This is -3. Next one, the cosecant of t. This is 1 over the sine of t. So I can write this as -3 divided by 2, square root 2, like this. Now, once again, if you want to not have a square root in the denominator, multiply by square root 2 divided by square root 2. We get -3 square root 2 over 4. Now we have 2 more. We need the tangent and we need the cotangent. So tangent of t, well, we take sine over cosine. So we have -2 square root 2 over 3. That's the sine. And then we divide by cosine, which is -1 over 3. You see what happens when I invert and multiply? I just get +2 square root 2. So I get +2 square root 2. This is the tangent. Now think about it. Does it make sense that the tangent is positive here? Well, yes, it does, because we're down here. In this quadrant, sine and cosine have the same SIGN. So when you take their ratio, you're going to get a positive. Okay, and you notice that here. We have 2 negatives, and in the end, we have a positive. Last one, we have the cotangent, which is cosine divided by sine. When we do this, you notice we get 1 over 2 square root 2, which I can slightly simplify. If we don't want the square root in the denominator, we can just multiply by square root 2 divided by square root 2. And I will get square root 2 divided by 4. This is the cotangent of this angle T. So similar to the last example, we were given cosine, or one of the trigonometric values. We were given the quadrant, and then we found the other 5. It's a great activity. This is the end of our exercises video for this lesson. Thank you so much, and have a wonderful day.